Okay, before you so rudely cut me off in the last video, yeah, you heard me right. Algebra students take crack. That's how you remember the signs in each of the quadrants for your trig functions. So in first quadrant, all of them are positive. And in the second quadrant, sine is positive. And in the third quadrant, tangent is positive. And in the fourth quadrant, cosine is positive. So algebra students take crack. Okay, so if sine is going to be positive, we know it's positive in first quadrant and second quadrant. So that interval would be everything from 0 to pi if I'm doing it in radians. Okay, so now this bad boy looks scary. So you can see I did f of g of x, and I plugged in the g of x over here. And there it is, there's g of x, that's what I knew it was. And then I'm going to take that and I'm going to plug it into the f function in place of the x. And so I get this crazy looking nonsense. Okay, so now a couple of things are going on here. I've got a radical inside a radical, and I know every time I have a radical, it's got to be greater than or equal to 0. So I'm going to look at the inner radical first, just to see what's going on with that. And let's see, 36 minus x squared, it must be positive. And if I solve that, I get x has to be between -6 and 6. Because remember, when you take the square root, you get two answers, positive and negative. And so think about this. Any number that I square, the squared part has to be less than 36. So if I start picking numbers between -6 and 6, any of those numbers that I square, their perfect square will certainly be less than 36. Okay, so right now, here's what's happening. Any number between -6 and 6 inclusive currently works. Okay, but then let's think about this as a whole. And so the entire contents underneath that square root has to be positive. So all of this has to be greater than or equal to 0. Look, I jumped it up here in the corner. Okay, so if I solve this, of course, I have to first move the 5 over. It's greater than or equal to 5. Then I'll have to square both sides to get rid of that square root. So I'll have 36 minus x squared greater than or equal to 25. And I'll move the x squared to the right and the 25 over. So I have 11 on this side when I subtract 25 from both sides, greater than or equal to x squared. And then when I take the square root, I get plus or minus 11. So x now sits between positive square root of 11 and negative square root of 11. Okay, so now when I transfer that over to here, square root of 11 and negative square root of 11 definitely live within this zone, but what just happened is I decreased my zone to only this red stuff, so that in an interval notation, I'm going from negative square root of 11 to positive square root of 11 for my domain values. Okay, now we got to do the other direction. Whew, sweat is beating on my forehead. Ooh, look at what we have here. So I got to figure out what f of x is. I knew what it was. It's square root of x minus 5. And I'm going to plug that in. And now I'm going to do g of that. So I got to plug all of this stuff into the g function in place of the x. And so it looks like this. And then I go, oh, goody, goody, goody. Because when I square a square root, I know that it makes it cancel out. So now I have just the stuff inside. And then I'm going to distribute and combine like terms. So I'm going to have a negative x, and 36 plus 5 is going to give me 41. And I know that the stuff inside that radical must be positive. So when I solve, I get, which says that x is less than or equal to 41. If I were to graph that, it looks like that. And in interval notation, it looks like that. See you in the next video.